This video is on wave calculations. Before you go and watch this, you need to already know wavelength and frequency, what they are and their units and such. So parts of a wave. You need to understand this first. So in order to calculate the speed of wave, we need to know two things. It's wavelength and its frequency. So we write this in symbols lots of times. So instead of speed of a wave, we use the letter V, just like when you did ninth grade, you did speed of anything. So V is speed, and that comes from velocity, and that equals the wavelength times the frequency. So for wavelength, we use the Greek letter lambda. So it kind of looks like a little wave, I think, with like a diagonal line coming down from it. Times frequency. Frequency, we use the Greek letter nu, so it kind of looks like this cursive, kind of funny little V shape. Make sure you're writing it like this, though, because you don't want to confuse it with the V, the letter V that is already in the equation. Wavelength, remember, has units. It could be any length units, meters, kilometers, centimeters, nanometers if it's really, really small. For this equation, though, it's going to need to be in meters. And your frequency, if you remember, has units of seconds to the -1, like here, or which is the same as 1 over seconds, which we typically call a hertz, and we abbreviate that Hz. So frequency has to be in hertz, which is 1 over seconds. Okay, so then your speed is going to be in units of meters. Whoops, let's try that again. Meters per second, because hertz is per second. Okay, we're typically talking about waves that are traveling at the speed of light, though. Anything on the electromagnetic spectrum is traveling at the speed of light. So we need to know what that speed is. It's always the same. In a vacuum, we're going to assume it's always going to be this. The speed of light, we use the letter C to symbolize that. It's 3.00 times 10 to the 8th meters per second. That's, pretty fast. So think about that. That is, if you write this number out, let's move this. So that is 300 million meters per second. 300 million meters. Think of 300 million meter sticks spread out. That's how far light's going to travel in 1 second. This is extremely fast. We aren't able to get anything to go that speed as of right now, but light does travel that fast. So we could rewrite this equation when we're talking about things on the electromagnetic spectrum. Instead of just V, we could write it as C. So anything at the speed of light is traveling at C, which equals the light wave's wavelength times its frequency. So let's do a practice problem with this equation. So here's the problem on your paper. A student is listening to the FM radio station B96 while doing their chemistry homework. This radio station has a frequency of 96.3 times 10 to the 6 hertz. Notice that number, 96.3 times 10 to the 6. That is the number on your dial that you turn your radio to get this. So that number, like KDWB, is 101.3. That's the number of megahertz, really. So that's why it's times 10 to the 6. If radio waves travel at the speed of light, what's the wavelength of these waves? So let's write out our givens here. We've got frequency of 96.3 times 10 to the 6 hertz. So I'm going to write that over here on the side, just like we did word problems like this in 9th grade. 96.3 times 10 to the 6th hertz. We write the number and the unit. And this is a radio wave. It's traveling at the speed of light. So we could say our speed is C, which is 3.00 times 10 to the 8th meters per second. And the question is asking for the wavelength. So that's my question mark. So now I write out my equation. So my equation is speed of light, C, is wavelength times frequency. Solving for wavelength, I need to get it on that in the equation on one side by itself. So I need to move frequency to the other side. So if I'm multiplying to get to the other side, I have to do the opposite, which would be divide. So if I divide by frequency here, anything divided by itself will cancel out. But if you do it to one side of an equation, you have to do it to the other. So my wavelength, I'm going to rewrite this, is the speed of light divided by the frequency of that wave. So speed of light, 3.00 times 10 to the 8th meters per second divided by my frequency, which is 96.3 times 10 to the 6th hertz. Okay, so when I type this in my calculator, remember with scientific notation, you have to use that EE or EXP button, whichever kind of your calculator has. Typing this in, type it in right now and see if you can get the right answer. So pause it here. You should get 3.12 meters. Why did I do 3 sig digs? Because both of my numbers in my problem have 3 sig digs. How do I know it's meters? Well, looking at your units in your problem, you have meters per second on top divided by hertz. Hertz is the same as 1 over seconds. So 1 over seconds divided by 1 over seconds cancels. So you're left with meters. That is a unit for wavelength. Okay? So now try the practice problem, write it out on your paper, and then answer the question in Moodle for the learning check.